Hi, this is Jameson Weber from Group 21 of CSC 574, presenting our running code for our project, which is entitled An Alternative to POMDP Value Iteration for Spoken Dialogue Systems. So here, we have created a spoken dialogue system with 8 different states. It's a customer service agent. It's essentially here to help you purchase some sort of phone, either an iPhone or a Samsung phone. The 8 different states that this agent can access are: it can either add an iPhone to your cart, or let you buy an iPhone, let you buy a Samsung, tell you information about an iPhone, tell you information about a Samsung phone, tell you information about a service plan, add a service plan to your account, cancel order, or confirm order. So for this, we provided sample inputs, sample transition function, a sample reward model, sample observation function, as well as a sample data set to allow this agent to understand English. Essentially, the data set's about 1,200 records long, and each record maps a specific set of raw text to an action. It runs it through 6 different machine learning classifiers, which we'll go into later. And then whichever action is or observation is voted for most by the machine learning algorithms becomes the observation for the POMDP to receive as input. And it also receives an associated confidence value that's based on the voting system. So essentially, if the mode of the so the machine learning algorithms create a list of observations. The mode of this list becomes the selected observation, and then the number of machine learning algorithms that voted for the mode divided by the total number of machine learning algorithms becomes the confidence factor. So let's get into the code running, and I will show you how the belief state updates and all the different things you can say to it to make it work. So let's get it started. Okay, so let's get it started. So the program is running, and I'm going to basically just start its process. So let's get started.
Hey, my name's Panda. I'm here to help you select a new phone.
Okay, so Panda has an initial belief distribution, as you can see above here. But now I'm going to start to talk to Panda and get this belief distribution to update. So let's just ask Panda if she can tell us about an iPhone. So let's go. I want to know about the iPhone.
The only iPhone we have available is the iPhone 8. This phone features a 5.5-inch LCD screen, a 12-megapixel dual-lens camera, and 64 gigabytes of storage for $699.99.
Okay, so let's see what happened here. It took my text, converted it into some bit vectors, which it then fed to each of these 6 machine learning algorithms. It looks like the vote for get info iPhone was completely unanimous, so it gave us a confidence level of 1. And then it gave us a new belief confidence, which is 0.74, which exceeded the threshold update of 0.5. So it went ahead and executed the action, do get info iPhone. And as you can see from this radar plot here, which kind of covers all of the different states, we're spiked greatly towards get iPhone info. But as you can see down here, there's a little bit of the belief distribution that is pointing towards buy iPhone, but the vast majority of it is get iPhone info. So I can ask this in many different ways. Let's try it again with a different way of asking. So, tell me about the iPhone.
The only iPhone we have available is the iPhone 8. This phone features a 5.5-inch LCD screen, a 12-megapixel dual-lens camera, and 64 gigabytes of storage for $699.99.
Okay, so now what I'd just basically like to do is go through all the different states and demonstrate that they're working correctly. So now let's get some information about a Samsung phone. So let's go. Can I get more information about the Samsung phone?
We have one type of Samsung phone in stock. The Samsung Galaxy S9 features a super speed dual pixel camera, infinity display edge-to-edge immersive screen, and an internal memory of 64 gigabytes for $599.99.
Let's ask this in a different way. So let's go ahead and say something like, what about the Samsung phone?
We have one type of Samsung phone in stock. The Samsung Galaxy S9 features a super speed dual pixel camera, infinity display edge-to-edge immersive screen, and an internal memory of 64 gigabytes for $599.99.
So, okay, so let's try something else. Let's do buy iPhone and buy Samsung. So let's first buy the iPhone. Let's say, I would like an iPhone, please.
Okay. I am adding an iPhone to your cart. What else can I assist you with?
Let's ask that in a different way. Add an iPhone to cart.
Okay. I am adding an iPhone to your cart. What else can I assist you with?
Okay, now let's try the Samsung phone. Let's see. I would like a Samsung phone.
Okay. I am adding a Samsung phone to your cart. What else can I assist you with?
So you can see, even though I majorly stuttered there, it still was able to understand what I was saying. So let's be a little bit more crass. Let's see. Give me a Samsung.
Okay. I am adding a Samsung phone to your cart. What else can I assist you with?
Okay, well, let's ask her about information about their service plan. So tell me about your service plan.
Our service plan provides our users with unlimited data for $59.99 per month.
Okay, let's go ahead and ask that one more way. How about, I want to know about your service agreement.
Our service plan provides our users with unlimited data for $59.99 per month.
Okay, let's go ahead and buy the service plan. Let's see. I want to set up service.
Okay. I have applied our service plan to your account. You will be billed monthly. Good luck with that.
Or even more simple, add service plan.
Okay. I have applied our service plan to your account. You will be billed monthly. Good luck with that.
All right, let's go ahead and confirm an order. Let's see. Okay, Panda, I'm all set.
Excellent. Your order has been confirmed. You will receive your order within 5 business days. Thank you.
Let's ask that in a different way. We'll say, okay, I'm ready to check out.
Excellent. Your order has been confirmed. You will receive your order within 5 business days. Thank you.
Okay, so the last state is to cancel order, and I'll just demo that really quick. Remove everything from cart.
Okay. I am canceling all transactions made during our call today. Don't worry. I will totally forget about all of this.
Cancel my order.
Okay. I am canceling all transactions made during our call today. Don't worry. I will totally forget about all of this.
Okay, another thing I wanted to demo is what happens if the machine learning classifiers don't really agree with each other. So I could say something to it that's not really in the context of purchasing a phone, and let's just see what happens. I want to be president.
I am not sure what you are asking. Can you rephrase the request, please?
Okay, so I said something that wasn't really accounted for in the data set. So, but still the classifiers have to pick something. So it looks like 2 of them, the support vector clustering, stochastic gradient descent, and decision tree and linear SVC all picked cancel order, whereas the multinomial naive Bayes picked by service and logistic regression picked by Samsung. So this made a confidence score that was kind of low of 66%. So this kind of pushed that belief threshold up to 0.9, and the belief confidence was only at 78%. And this caused it to do like a clarifying action instead. So and then the only other thing that I wanted to show was how it handles negative words. Essentially, if I say I don't want to buy an iPhone, then it shouldn't. If I didn't handle that, then it would just sort of default to buying an iPhone. So let's just see. I don't want an iPhone.
Instead of telling me what you do not want to do, tell me what you actually want to do. Okay, thanks.
Okay, so that's it for the presentation. If you want to try to get this to run yourself, I will be providing a README file. There's a lot of dependencies. I just wanted to go through the code really quick and how it works. So the first section of the code is mostly reading our input file, which is where you put in your transition function, reward function, all the POMDP inputs that are required. So that's what all this does. Let's see. Yep. Okay. And then down here is where it reads the data set, the CSV file that contains all the records so that allows you to talk to Panda. And this section of code here is where it fits it to each of the classifiers. And then down here is where we kind of get into the meat of our paper. This here is calculating the expected rewards, and then it's taking those expected reward values and calculating the initial dynamic thresholds, and these are the formulas you can find in our paper. This function here is how it plots the radar plot to help visualize it. In here is this is our benchmark algorithm. This is the filtering update for POMDPs and hidden Markov models. And from this, if you give it an evidence or an observation and some action, and it chooses an action to execute based on that, updates the belief distribution and returns some sort of reward. This little class here is the listening device that allows Panda to take the audio signal. This is the machine learning vote function. Each of the 6 machine learning algorithms we put in, they each make a prediction based on some sort of based on the raw text input. And then it returns, they vote and it returns a confidence score. This is like an NLP tool to help, this converts an input text to a bit vector. So it'll create the weights for the input. This is from our paper too. This is the update threshold function. This formula is also in the paper. This is how Panda executes actions, and this is like the code for her playing each of the sound files that she can do. And then finally down here is the main loop where you can just sort of ask her stuff as much as you want. And this just says the high-level logic of the program. Okay, so again, if you have any questions, feel free to email me. I will be submitting the code and a README file of how to install it if you want to. If you need any more information, just let me know. Okay, thank you.